Alrighty, so we're going to talk about question 6 from the 2018 exam. And it says cystic fibrosis is a genetic condition that is associated with defects in the CFTR protein. The CFTR protein is a gated ion channel that requires ATP binding in order to allow chloride ions to diffuse across the membrane. And so it says in part A, it says, in the provided model of the cell, draw arrows to describe the pathway for the production of normal CFTR protein from gene expression to final cellular location. And so we need to take the, we need to be able to go from the nucleus, and then you draw an arrow to the ER, and then you draw an arrow from the ER to the Golgi, and then you would draw one out the plasma membrane. So that's just the order that we talked about in class about getting it from the nucleus. So where this says from gene expression, that's what I was looking for, to the final location, which would be getting it outside the cell. And then B says, identify the most likely cellular location of the ribosomes that synthesize the CFTR protein. And you might say, oh gosh, there's two, I'm not really sure. But if you go back up to the top, it talks about having to cross the membrane. If something has to leave the cell, it has to be packaged. And so if it has to be packaged, then it has to go through the endomembrane system. So then you would say that they were the ribosomes on the endoplasmic reticulum. And then for C, it says, identify the most likely cellular location of a mutant CFTR protein that has an amino acid substitution in the ATP binding site. And if we go back up here to the top, it says the CFTR protein is a gated ion channel that requires ATP binding in order to allow them to diffuse across the membrane. So there's two clues up here. One, it's somewhere near the membrane, but the biggest one is the gated ion channel, which if you remember from class, that was located within the membrane. And so then this one would be the plasma membrane. So pretty simple.